Zoran's Cosmic Puzzles, fun math puzzles and activities related to the universe for readers to solve. Hello again, cosmic adventurers. It's me, Zoran the Dragon, back to test your wits with a series of puzzles that will take your brain on a journey through the stars. In this chapter, we'll have fun with math challenges inspired by the vast universe we've been exploring together. Are you ready to solve some cosmic mysteries? Let's begin. Puzzle 1. Counting stars in a constellation. We're floating above Earth, looking up at the night sky. Let's focus on a famous constellation, Orion, the Hunter. Now, I have a question for you. How many stars can you count in Orion? Let's say you see 3 stars in the belt of Orion, 2 stars forming his shoulders, and 2 more stars making up his feet. How many stars are in Orion's constellation altogether? Hint: use addition to solve this, to find the total number of stars in Orion's constellation based on your description. We simply add up the stars in each part. 3 stars in the belt, 2 stars forming his shoulders, 2 stars making up his feet. So, the total number of stars is 3 plus 2 plus 2 equals 7. Did you get the answer? The total is 7 stars. Orion might only be a part of the sky, but his stars come together to create a recognizable pattern. Fun fact: constellations like Orion have been used for centuries by navigators and astronomers to map the skies. The number of stars we can see is just a tiny fraction of what's truly out there. Puzzle 2. The mystery of planetary orbits. Now, zoom in on the planets in our solar system. Did you know that planets orbit the sun in paths shaped like ellipses? Let's play with the concept of orbits using math. Imagine that the orbit of Mars around the sun takes 687 days. Now, how many Earth orbits, which take 365 days, each can fit into one Martian year? In other words, how many Earth years does it take Mars to orbit the sun once? Hint: this is a division problem. Divide the number of days in a Martian year by the number of days in an Earth year. The answer is approximately 1.88 Earth years. So while we experience one trip around the sun, Mars is still traveling on its longer path. Fun fact: the elliptical shape of orbits was discovered by Johannes Kepler, who used careful observation and math to describe how planets move. His work laid the foundation for our modern understanding of planetary motion. Puzzle 3. How big is the universe? Let's dive into the scale of the universe with this next puzzle. Imagine you are trying to count how many galaxies there are in the observable universe. We know there are around 100 billion galaxies. Now, if each galaxy has an average of 100 billion stars, how many stars are there in total? Hint: multiply the number of galaxies by the number of stars in each galaxy. 100 billion galaxies, 100 billion stars equals? That's a whopping 10 stars, or 10 sextillion stars. The scale of the universe is almost too big for our minds to grasp, but with math, we can begin to understand it. Fun fact: the Hubble Space Telescope and other powerful tools have allowed us to observe distant galaxies, giving us a glimpse into the vastness of space. The universe might contain even more galaxies than we can see. Puzzle 4. Zoran's magic number sequence. Now, explore a fun number pattern that shows up in nature, the Fibonacci sequence. This sequence begins with 0 and 1, and each number after that is the sum of the 2 preceding numbers. Here's how it starts: 0, 1, 1, 2, 3, 5, 8, 13, 21. Can you figure out the next 2 numbers in this pattern? Hint: to get the next number, add the last 2 numbers in the sequence. 13 plus 21 equals? The next number is 34, and after that comes 55. Fun fact: the Fibonacci sequence shows up in many places in nature, from the arrangement of leaves on a stem to the spiral of galaxies. It's a pattern that connects math and the cosmos in a beautiful way. Puzzle 5. Speed of light challenge. Let's get super fast now and explore the speed of light. Did you know that light travels at about 300,000 kilometers per second? That's the fastest thing in the universe. But how long does it take light to travel from the sun to Earth? We know that the distance from the Sun to Earth is about 150 million kilometers. So, to find how long it takes light to travel this distance, we divide the distance by the speed of light. The answer is 500 seconds, or about 8.3 minutes. That means when you see sunlight, you're actually seeing light that left the sun over 8 minutes ago. Fun fact: this time delay means that if the sun were to suddenly disappear, don't worry, it won't. We wouldn't know for over 8 minutes because it takes that long for the last rays of sunlight to reach us. Puzzle 6. The cosmic triangle. For our last puzzle, let's explore a geometric challenge. Imagine a triangle formed by 3 stars in the sky. The angles of any triangle always add up to 180 degrees. If one angle in this cosmic triangle is 60 degrees and another angle is 70 degrees, can you figure out the third angle? Hint: to find the missing angle, subtract the sum of the known angles from 180. 180 plus 70 equals. The answer is 50 degrees. Fun fact: triangles are important in astronomy. Astronomers use triangles and trigonometry to measure the distance to stars and planets through a method called parallax. By observing how a star appears to move against the background when viewed from different positions, scientists can calculate its distance from Earth. And there you have it, my brilliant cosmic thinkers. These puzzles were just a taste of the wonders we can uncover with math. The universe is full of patterns, shapes, and numbers waiting for you to discover. Each time you solve a problem, you're not just playing with numbers, you're exploring the mysteries of the cosmos itself. So until next time, keep your mind sharp and your curiosity soaring like the stars. I, Zoran the Dragon, will be here, ready to guide you through the next adventure in our mathematical journey through the universe. This chapter blends fun and educational math puzzles with factual cosmic themes, encouraging readers to think critically and solve problems. Each puzzle connects to real-world astronomical concepts, making the chapter both engaging and informative.